Thank you for coming. And Father came 2 years ago to receive the Mendel Medal. So, I'm an astronomer, so we have commonality. I want to introduce Father. He doesn't want this to be too long. I told him it was an hour. So, it's a few minutes. Father, at 18, he was born in Baltimore, which is nearby. I even said it correctly.
You did.
And he joined the Jesuits at 18 years old. And he received a BS in math, licentiate in philosophy. I asked him what a licentiate was. It's like a master's degree. And at the same time I left it out. You had a sacred theology licentiate. I don't know how you did both in the same year, but you did that.
Didn't study much.
PhD in astronomy at our rival Georgetown. Ordained a Roman Catholic priest in 1965. Visiting assistant professor at the University of Arizona. Now it's going to play into his role in life because there's very good links between the Vatican Observatory in Arizona, thanks to Father. He worked at the Lunar and Planetary Lab, and then we go on to the next page. So we have, he was an astronomer, appointed astronomer at the Vatican Observatory. He'll be talking about that. It has a long history, 400 years of astronomy there. Appointed director by himself, Pope John Paul I in 1978. Associate professor at the University of Arizona, and actually he was the acting director, head of the department there. That prepared him for his job as, let's see where he was appointed, director of the, probably got that out of order. He retired in 2006, but he's far from retiring. He's written some books, done lectures, and he's the president of the Vatican Observatory Foundation. Now you're going to see some big telescopes and things like that. That money doesn't come from the collections. It's from a foundation, a private foundation that he's been raising money for. So these are some of the things. Father also helped when he was director of the Vatican Observatory. They have a Vatican summer school, Vatican Observatory Summer School. It's a beautiful place. This is the Pope's summer residence. You can see telescopes there, and it's a beautiful town. And they have they invite every 3 years, they have people mainly from developing countries, Africa, Philippines, all over. And well, in addition to that, in that time, we had 2 Villanova students chosen. And they enjoyed it. One student got to kiss the Pope's ring, which was the irony of, and George's ring. So it's a beautiful place, and this is one of the schools in 1999, an early one. So he also established an astronomy research group. This does modern astronomy, spectroscopy, photometry, polarization, stuff like that. And that was a combination. The Vatican, or Catholic Moldova, doesn't have great weather, but Arizona does. So this involved building a telescope called the Vatican Advanced Technology Telescope. You'll see a picture of it. It has a wonderful mirror, and it's located on Mount Lebanon. And we'll be talking about that maybe. Okay. I don't know what there's an observatory. It's called the VATT, V-A-T-T, and this is they also involved, strangely enough, not strangely enough, in a very large telescope called the binocular telescope, which is to the right. You can see it's like binoculars. And they were involved in the construction of, it's hard to get have Lucifer out of this, but you see it's the large binocular telescope. You have to stretch things to get it to mean. Lucifer is a nice thing for the Vatican. So that's an instrument that was partially funded, partially built by the, so they have a tie-in to this large telescope. It's 8 meters, 2 of them, 8 meters across. And Father did research, or does research, in areas that overlap with my own. So he has included polarimetry, that's used polarization, that's where you can polarize glasses, and it's like that. He did studies in that of variable stars, cataclysmic variables, that's one over here on the right, on the left-hand side. These are binary stars every once in a while blow up, which is exciting, they're noted. He discovered medium, sacred galaxies, and numerous publications, and he has recently written several books. The books are mostly in the area of astronomy, biology, and ethics, and things like that. Honors and awards. I'm almost done, Father. I didn't want to embarrass him. He said, keep it to a minute. I'm sorry. So, honors and awards. So he has doctorate degrees from all of our rival schools. I'm going to Villanova is not there in that list, but you see Boston College. Well, the Polish school isn't such a rival. Loyola, Marquette, St. Peter's, and the University of Padua. And in addition to that, at Villanova, he received what the highest award that we can give in terms of science is the Mendel Medal. And that was awarded in 2009. Maybe some of you were back at the event. That's the Mendel Medal on the right side. All this is eclipsed by the fact that an asteroid was named after your father. It was called George. No, it was called 14429 coin. And I even have a picture of it. Well,
where'd you get that?
Here is the orbit. You see the Earth is that green, that blue line is the Earth. You see the asteroid's orbit. Fortunately, it doesn't come. These are asteroids. These are things a few miles across to several miles across. And the good news with Father Coin's asteroid is it doesn't hit us. I mean, that would be very bad. It'd be very bad if it was one of these ones that was going to crash into the Earth, like the one that knocked out the dinosaurs. So Father's, his namesake is a safe mark. It's a nice stable orbit in the asteroid belt. And so without any further ado, Father's going to be talking on children of the fertile universe, chance, destination, creativity. I got this out of 2001, of course. So Father is coming up next.
Thanks, Ed. Very nice. Very nice indeed. Can you hear me? Do you want to hear me? Yeah. Okay, thanks for the applause. We'll see what happens at the end. And thanks very much, Ed. That was a unique introduction. So unique that except for the photographs, I didn't recognize myself. And even the photographs, I look in the mirror this morning and, my hair is less curly a little bit there. No, I never really recognized myself in these introductions because I grew up in a family of 10 children. And so I'm used to it. I'd come down the stairs. Mom was trying to get 8 children at the time to elementary school, high school, all at the same time. So I'd come down the stairs and she'd say, Richard, no, Mom. James, no, Mom. Stephen, no, Mom. Who the hell are you? I'm just George. Oh, George, I love you, etc. And then I hate to add to the introduction, but there is one small note, that I was appointed director of the Vatican Observatory by John Paul I. And you older folks, there are a few around, know that John Paul I only lived for 32 days as Pope. So my friends, mostly Jesuits, if you have a Jesuit as a friend, you don't need an enemy. They suggested that, there were many rumors going around that John Paul I was poisoned. There was a plot, and there are lots of plots in the Vatican, but no. He was overcome by the weight of the job, even the guy who got into it. No, the real cause of his death was at the end of 32 days, he reconsidered some of his appointments, of which I'm one, and he went to the Lord. Well, let's get more serious now. I do want to share with you my knowledge of the universe as a scientist. But since, despite the fact that I'm a Jesuit, I'm also a religious believer, so I'd like to share with you a few thoughts from my view of the universe as a religious believer. I think the important ideas here are how can I call us children of a fertile universe? First of all, what do I mean by a fertile universe? And therefore, how can I scientifically call us children of this fertile universe? And then the real question I want to address is that all of this happened by chance or by destiny, and then the religious implication of, is there a creator God? Well, let's address the question straight out. Did the universe and ourselves, can you still hear me? Yes. Do you still want to hear me? Yes. Okay, let's forget that. I assume you do. This question, which is a classical scientific, philosophical, as you want, question, goes back many centuries, obviously immediately has a religious implication. If we came about by chance, who needs God? And that could be true. We could have come about by a purely chance, random process. As a matter of fact, science defies that conclusion up until today, that it did not happen by purely random chance processes, but it could have, and therefore who needs God? It just happened. But if it happened in somewhat of a systematic way, it was designed, it was necessitated, who did it? So the God question is embedded in what I consider to be a scientific question. However, the scientific question, chance or necessity, is inadequate according to modern science, because it is both chance and necessity in a fertile universe. So there's a third element that dominates the whole interplay between chance and necessity, and that's science. So that's what I'd like to share with you first of all. How can I say that as a scientist? What do I mean by a fertile universe? I essentially mean two facts, scientific facts about the universe. The universe is 13.7 billion years old, plus or minus 0.2. And we know that. Today, if we get more data, we may revise it tomorrow. That's the way science goes. But from several independent scientific investigations, chemical abundance in the universe, the ages of the stars in the universe, the expansion rate of the universe, how long it's been expanding, etc., they all converge upon this one number. So it's the best number we can give you for the age of the universe as science goes. Obviously, according to our experiences, as you'll see in a little bit, it's a very big number. But in that universe, we have 10,000 billion stars. I say it this way for the non-scientist. This is 10 to the 22nd. That's one with 22 zeros behind its stars. And I know that. I know that within a very, very large probability. It may vary by a few billion here or there. Who cares? I know it that well. So I want to build upon these two very well established scientific conclusions to talk about the fertile universe. From the Big Bang, which happened 13.7 billion years ago, the universe has been getting bigger and expanding, and things have happened. Stars have been born, galaxies have been born, we've been born, as we'll see shortly. If the universe is 13.7 billion years, we're out here. 13.7 billion years since the Big Bang. So we look back with Hubble telescope, the large telescopes that we're developing on the surface of the Earth, and we take pictures of the early universe. That is the universe when it was only less than 1 billion years old. We've seen back that far. And what do we see? That's what we see. So you say, what are you so excited about? On this one photograph that was taken by Hubble in 40 orbits, looking at a piece of the sky that if I extend my arm, it would be 1/20th of the width of my index finger, okay? Hubble looked at that very small part of the sky in order not to see nearby objects. You know, if I want to see New York City, I don't know where I'm looking now, but I'm going to take a very narrow view so I don't see your heads. So I go through you to the very distant universe. And that's what Hubble did, and this is what it saw. So imagine how small a part of the universe we're seeing. Nonetheless, on this slide, I see 1, 2, Katie, help me out. There are there are 3 other stars here. There are 5 stars on this photograph. Every other dot of light, unexciting, is a galaxy that contains of the order of 100 billion stars. Some smaller, some larger. So if you don't believe me, let's sample a few. Here's an irregular galaxy that contains somewhere between 1/10 and 1/2 of the mass of our galaxy, therefore of the stars of our galaxy. There's an elliptical galaxy which can contain of the order of 5 times the number of stars in our galaxy. By the way, and it's just a by the way, this elliptical galaxy is eating up a little baby galaxy. We call it galactic cannibalism. And that's why some of these galaxies get big, by eating up little babies. The universe is very creative. And there is a galaxy like our own, a spiral galaxy, that contains of the order of 100 billion stars. Okay? So this is the reason why, since this is so small a view of a universe that we could examine 360 degrees around, that statistically we can establish the number of galaxies in the universe, which is about 100 billion. And 100 billion stars in each, on the average, gives us 10,000 billion stars, plus or minus a billion or so in the universe. One of those galaxies, to examine a little more in detail, is the Andromeda Galaxy, which is a sister galaxy to our own galaxy. So our own galaxy is very similar to this. As I said, it contains 100 billion stars. It measures 100,000 light years across. Now, for non-scientists, I have to stop. I said light years. And of course, you teachers of undergraduates and I myself can catch students all the time. What is a light year? Well, it's a measure of time. It is not. It's a measure of distance. It's the distance light travels in a year going at the velocity of light. So the distance across here is 100,000 light years, meaning if I'm down here and I'm talking to my grandmother up here, and I say, "Grandma, how do you feel?" and our voices travel at the speed of light, which they do not, 200,000 years later, I'll hear Grandma say, "Son, my knee's giving out. I'm not playing tennis like I did." Now, the reason I pause on this is to impress upon you that as we look out in the universe, we're looking back in time. Light travels very fast, but at a finite speed. So the galaxies that Hubble saw, the most distant ones, we're seeing as they were less than 12 billion years ago. So they're only less than 1 billion years old. They're very young galaxies. And the Andromeda Galaxy that we see is a very old galaxy because it's nearby. It didn't take its light very long to come to us. Now, if we're clever enough, and we look at objects at different distances in the universe, we can try and replay how a young galaxy got old. And that's very important because galaxies are the building blocks of the universe. This is a depiction of a typical galaxy like our own. It has a bulge, spiral arms. Typically, the younger stars are occurring in the spiral arms, the older stars in the nucleus and the halo population. But we're not going to go into a lot of detail about that. The galaxy is a very flattened system. It's like a tabletop. It's about 200 times longer than it is thick. And in our galaxy, we are, the sun and the planetary system are about 2/3 away from the center of our galaxy, which measures, as I said, 100,000 light years across. Well, when we look, see, we're in the galaxy. So to look outside our galaxy, it's very difficult if we look along this way, because to examine our galaxy we look that way, but we're looking along all the gas and dust that obfuscates the light. So to see distant galaxies, We want to look up and down this way. Any rate, we want to know a little bit more about our galaxy, so we look out along the plane of our galaxy, and this is what we see. We see myriads of stars. There are so many stars here, that's not a cloud. That's stars that we cannot resolve, just piled up. But what I'm interested in for purposes of tonight's talk are these dark areas here. See the incandescent gas? All these dark areas? What's it all about, Alfie? Well, let's look at one of them in a little more detail. This is a dark cloud, the North American Nebula, aptly named. I mean, it really is marvelous that it resembles North America, right? There's the Yucatan Peninsula, there's the Gulf of Mexico, there's Alabama, Mississippi, Georgia, Florida. Little fogged over, but it has been since the elections of 2000. I still get a laugh, Katie. She's heard this. And we're not doing a whole lot better, but that's... Why are there so few stars in the Gulf of Mexico and so many stars in the southern states? There are not few stars in the Gulf of Mexico. It's filled with stars that are embedded in this dark cloud. That is a stellar womb. And if we could penetrate it with infrared light, we would see the stars being born out of this gas and dust. So in this case, and in many cases in astronomy, what you sees is not what you gets. You have to investigate further. So what I've said, this is a stellar womb. And if we look at a stellar womb in more detail, this is the center of the Orion constellation, the Orion Nebula. We see this incandescent gas, and as we look with Hubble in more detail, blown up, we see that there's a fairly nice separation of blue gas from red gas. You know, it's a bit chaotic, but you have to admit that the red gas is there, the blue gas is. Why? I mean, typically you look at it and say, isn't that pretty? And it is, but what does it mean? And we know what it means. Sorry to be so emphatic, you know, you think we know everything. It's a lot we don't know, but what we know, we know. And we know that this red gas is due to the fact that the most energetic, massive stars, which are always born first in this gas, are the most energetic. They're radiating the gas, it's absorbing the energy and re-radiating it in the H-alpha line of hydrogen, which is in the pink-red region of the spectrum. So the fact that it's red is an indication of a stellar womb. This gas is blue because it's too far from the star-forming region. It doesn't absorb that energy, it reflects it. So it's blue for the same reason that at least the sky over Arizona and sometimes over Villanova and Philadelphia is blue. Because the molecules, dust particles, etc., in the Earth's atmosphere are scattering the light from these energetic stars the same way that the light from the sun is being scattered by the Earth's atmosphere. So this is called a reflection nebula. It's called an emission nebula. They're star-forming regions, well identified for many reasons, but one is simply looking at it and seeing what the color of the gas is. Well, here is even a more detailed picture of the Orion Nebula, where you see the incandescent regions, the red gas, and the blue gas. How are stars born? In a little more detail. A piece of a black cloud begins to fragment by an interplay of gravitational, magnetic fields, etc. Okay, a shock by a supernova explosion. At any rate, this cloud begins to break up, and a fragment of the cloud begins to collapse. And as gas collapses, it heats up. As it expands, it cools down. We all know that from physics. But in this case, the mass is so great that when it collapses, it raises the interior to millions of degrees and turns on a thermonuclear furnace. That's what a star is. twinkle, twinkle, little, that's nice. But a star is a thermonuclear furnace that is radiating that energy created in the furnace to the universe. Now we have to pause just for a moment. Thermonuclear furnace. Simply what's happening is from the quarks in the early universe, you get hydrogen. Okay, the first stars are born out of pure hydrogen. That hydrogen in this thermonuclear furnace begins to convert by the fusion process into helium, a natural atomic bomb if you want. And as it converts to helium, it gives off energy through Einstein's E equals mc squared. Very well known. And if it's hot, if it's massive enough, once it's converted a certain percentage of hydrogen to helium, it'll collapse again, raise the temperature even higher, and convert helium to carbon. And then if it's massive enough, carbon to nitrogen to oxygen, all the way up to iron. So the most massive stars can create even the heavier elements. But a star like the sun, I believe it will not be able to convert carbon to nitrogen. Is that right, Bob? I think it cannot convert. It will not be massive enough to raise the temperature. So it will stop once it's converted helium to carbon. So you get the picture. What happens, however, is stars. This is a very beautiful example of a fragmentation of a cloud, breaking up into stars, beginning a reflection nebula. What is this? This is a dead star. And this is another dead star. That's what the sun will come to be in about 5 billion years. It's about 4.5 billion years old. So don't get all worried, 5 billion. Still time to get to confession if you have to and stuff. You noticed how peaceful the death was here, a smoke ring that goes out to the universe, right? But here you have a very dramatic explosion. Look at that little star there. Explodes and becomes this star in about 5 days. If you don't believe me, do what astronomers do. See those two, there are those two. See those three, there are those three. This is identically that star. In 5 days, it increased its energy millions of times. It's what is called a supernova explosion. And this is a good example of a supernova explosion. It's a chaotic death, not that peaceful smoke ring to the universe. The most massive stars die in this way and create the most abundant, the heaviest elements in the universe. So this, after about 200 million years, will look like this. Now, I haven't been around 200 million years. You may think I am. But from what I said before, we look at objects at different distances, so we can sort of get the evolution, the aging of objects. And besides that, we can measure the velocity of the gas that's expanding away from this explosion, and we can project how many millions of years it will take it to look like this. At any rate, these supernova explosions, these less massive stars exploding in the universe, from the material that they blow out to the universe, another generation of stars is born. But this second generation of stars, the first was born of hydrogen. The second generation of stars is born of hydrogen, some helium, some carbon. And the third generation of stars, some nitrogen, oxygen. The sun is a third generation star, and we know that very well from the lines in its spectrum. And if it were not, you and I wouldn't be here. It's a simple scientific fact. The sun, we needed 3 generations of stars to create the chemical elements to make life. There's no other way. If you have another way of creating enough carbon, nitrogen, oxygen to make life, let us know. The only way we know is through the generation of heavier elements through the thermonuclear processes in the birth and death of stars. Well, That being said, well, let me say, why am I talking about the birth and death of stars for a fair part of this talk? Because it's what makes us children of the universe. We are born of stardust. That's scientifically true. I mean, I have a professor friend at the University of Arizona who says we're born of thermonuclear waste. It's the same thing, but I get a smile when I say stardust rather than thermonuclear waste. Well, the process is well known. So we're children of the universe. Now, let's focus in on ourselves a bit. Around one star, the sun, this happened. All the material left over, the sun died, like I showed you, little point of light. Threw out this smoke ring, okay, which expanded in the universe, but there was a lot of material around the sun, okay, which now, as the sun began to rotate, had to collapse into a disk to conserve angular momentum, very well known in physics. So all that material in a disk is much denser, it collides, and through what we call the snowball effect, it builds up planetesimals, and finally planets, and we get a planetary system. This did not happen by a miracle. No, we don't know everything in this process, but we know substantially how a planetary system comes to be. Now, since it happened around the sun, you're going to ask me, so eventually, so I'll ask myself, did it happen around other stars? Well, if you'd asked me 15 years ago even, I have said almost certainly, because it's such a normal physical process. Today, I can say yes, because we have discovered almost 500 planets around other stars. Discovered. And the Kepler satellite has got thousands of candidate planets, which we have to investigate more carefully. So the science is really going forward with respect to discovering an Earth-like planet around a sun-like star. But we're not there yet. And the reason is we haven't been at it very long, as I'll try to show you in a moment. But we're going there. So the whole question of conditions for life elsewhere is a side issue for me tonight, but I'd be happy to address it. For now, I want to concentrate on us. So out of this vast universe, this little grain of sand came to be. Now, honestly, it is a grain of sand. I mean, it's one of 8 planets, around one star of 100 billion stars in our galaxy of 100 billion galaxies. And with the number of planets we're discovering, the fertility of the universe for planets is really beginning to more and more establish. So this is a little grain of sand, but it's precious for many reasons. But one that I like to concentrate on, because I don't think we scientists realize enough what happened with the birth of modern science, with Galileo and then on, through Descartes, Newton, Einstein, and into today. Through physics, mathematics, chemistry, biology, the sciences, we can put the universe in our heads. I can tell you the mass of this galaxy, and it's billions of light years out there. And I can tell you its mass because I study its rotation. And the reason it's rotating is because of the law of gravity. So the speed of its rotation at various distances from the nucleus tells me what the total mass must be. I can do that applying the laws of the natural sciences that I know here on Earth. And that's a marvelous thing. However, do note that I made a big assumption. I assumed that the law of gravity, angular momentum, chemical combinations, biological development happen there like they do here. Does the law of gravity work out in even the Andromeda Galaxy? much as those galaxies 12 billion light years away, the same way it does here? I have no way of knowing. I have to assume it. Because if I don't make that assumption fundamental to all the sciences, I can do no science. And that would make me, I don't know, into an alkie. I guess I'd drink gin and tonics under a palm tree and I'd be bored to death. So making that assumption is necessary in order to be sane. But there is another thing about this. I can't prove that assumption. But once I make it and using that assumption, study the universe, I get what I call a coherence. It all makes sense. That is, the masses that I determine are distributed in a way that fits the Milky Way. As far as the Milky Way, the way it looks, it fits it into this whole pattern of galaxies. The rate of star formation and the number of stars in the universe, they all kind of fit together. So I'm not going to go into detail about that, but the proof of the pudding is not in proof, but in coherence. It makes sense. So that's important. It does make sense. Well, let's back up a bit so that we can approach the real questions, and that is return to the fertility of the universe. The universe is 13.7 billion years old, as I said. I'm only 125. I'm trying to rival Moses. I think he got to 156 or so, but no, whatever age you want to have, I have no idea of what 14 billion means. So do what mathematicians always do in order to make sense. Scale down the number so it fits into something you know. So let's make out the universe, scaled down, is 1 Earth year, okay? And what do you see? Well, of course, it all began on 1 January. We haven't talked about the beginning, and we're not going to. The dinosaurs were born, fortunately, on Christmas Day. But they were only around 5 days. But the thrilling thing to me, and it's thrilling, I think it's just thrilling, is the last day of this year that represents the age of the universe. We human beings came to be 2 minutes ago. Jesus Christ, 2 seconds ago, and Galileo, a second ago. This is the way it works, folks. The universe is so old that our human knowledge is dwindled. All of our prehistoric and historic and written knowledge becomes this. Now, you could put any religious figure you want on here. Put Abraham, Isaac, Mohammed, it'll only change that by a few milliseconds. I, for my own purposes, put Jesus Christ because it means a little bit more to me, and I suspect to most of you. But the point is, if we have not absorbed everything that God said to us, give us a little more time. Even in his Son, he's only spoken for 2 seconds in a 1-year-old universe. So if we haven't sort of gotten along together, Christians, Jews, Islam, etc., God's still trying to work his way with this stubborn people who have only been listening for 2 seconds. And then if I don't reveal much ignorance tonight, because that's not the purpose of my lecture, but you'd be surprised how ignorant we are. But give us a little more time. I mean, we scientists, cosmologists, astrophysicists, and all the other sciences have been studying a universe and its contents for 1 second, and it's a year old. Well, that being said, what happened to this universe is reviewed here very quickly. The universe got older. This should be 13.7, but I haven't changed it. That's now. And as the universe got older, distances got larger. That's what the expanding universe is. And things happened. Now look, because I put an arrow point here doesn't mean I know the exact time, nor the sequence. It's very much debated today as to whether galaxies came first and then stars formed in them, or where stars formed and then aggregated into galaxies. From modern studies, it appears to be that both processes were taking place in the early universe. But that all aside, having revealed that degree of ignorance, I want to ask again, why did it take 2/3 of the age of this very old universe to get an amoeba? Well, we know one reason. There are others. It took 3 generations of stars to get the chemical elements to make primitive life. And if you do a little bit of mathematics, 3 generations of stars puts us at about 12 billion years. Of course, generations overlap. Like grandchildren, even great-grandchildren, live with great-grandparents, etc. Generations overlap. The sun is about 5 billion years old. So you can have 3 generations of stars in 12 billion years. And so it's coherent again. Okay? The picture is coherent that after 12 billion years, we had the chemical abundance to make life. Well, now we can't stop there because we're here and we want to know, how did we come to be over this period of time? Now, this is the hot topic that I know very little about, but that will not prevent me from talking about it. Because I think it's well established, okay? And I'm willing to accept criticism of this because I'm doing it very schematically. But the best scientific knowledge of our coming to be in this universe is through what is called neo-Darwinian evolution. Neo, because Darwin didn't know about genetic mutations, etc. So Darwin's theory has been modernized with new knowledge. But his fundamental idea was that you have mutations in an organism. It changes through processes we now know, genetic mutations. This organism, okay, in order to go into the future to survive, has to adapt to an environment that is changing also. And so it only survives if it changes in order to adapt to the environment. And fortunately, as I'll show in a moment, the way chemistry goes, the survival always creates a more complex organism. So you go through the origin of species, is Darwin's word for it, is that once you had life, it went through an evolutionary process till we got to the human brain. Now look, there are all sorts of leaps in this picture. But paleontology, geology, molecular biology, genetic studies now, all lead to the same conclusion. So it's very difficult scientifically not to accept what Darwin's original view was, modernized, that we came about through an increasing complexity of organisms because of what Darwin really, he observed, but he really intuited that there is an adaptation to the environment which leads to ever more complex organisms. He called it natural selection, survival of the fittest. The words all mean the same thing. Let's look in a little more detail. I can't get into genetics, but I can get into a little bit of molecular chemistry. How did this happen, this buildup of more complex organisms? Well, we know through ever more complex chemistry. Now, I don't know enough chemistry to identify these molecules unless they're indicated here, but we get to the sugars, the amino acids, the proteins, the prebiotic organisms, molecules. Take this, well, look at it. C and HO repeat themselves. Hydrogen, carbon, nitrogen, and oxygen repeat themselves, but ever in more complex molecules. Let this process go on for 14 billion years, building up ever more complex molecules, and you'll get the human brain. That's the way chemistry works. There's chemical decombination, obviously. But we're here. So it's obvious that the buildup of more complex molecules won out, for whatever reason, against the decomposition of molecules. So let me come to the close of the scientific part by asking, what do I mean by chance, essentially? And what I mean by chance is a very, very simple, because I can't handle any more complicated idea, is that two atoms of hydrogen meet in the early universe. They have to make hydrogen molecule. They have no choice. That's what chemistry is all about. So it's destined, it's necessitated. But they don't at this time and place in the universe because the pressure and temperature conditions are not correct. So they don't combine. So they wander throughout the universe. They meet trillions of times. There are trillions of hydrogen atoms from all of these stars pouring out chemistry. What is to surprise us if a few million, a few billion times we get a hydrogen molecule? Now we can put a probability on that. It's not pure, random, it just happens or doesn't happen. Around some stars, in some galaxies, the temperature and pressure conditions are more suitable for this combination. And we can study that. So we get two hydrogen molecules. They meet in oxygen. They have to make water. But they don't at this time and place, et cetera, et cetera, et cetera. So you go on for 14 billion years, all building up this more complex chemistry, some of it decomposing, but going forward to more complex chemistry until you get the human brain. Did this happen by chance or necessity? By both. If the conditions were correct, and they're not always correct, so there's a probability, a chance that they will be correct, then this will necessarily happen. So you have both chance and necessity, but in a fertile universe. And that's a very important ingredient. If you have enough chemistry, okay, this is going to go forward inevitably to more complex organisms. So I put this tree up here to terminate this discussion. This tree contains everything that ever happened in this universe. So the first galaxies, first stars, first hydrogen molecules, the birth of my grandmother, my first toenail, whatever happened in the universe is here, even the processes that failed. So we've been able to record all those hydrogen atoms that never made a hydrogen molecule. They're all here. Blow a quiet breeze through this tree, knock off all the dead branches, the dead leaves, and what do you see? Because chemistry is what it is, and the universe is what it is with chemistry, physics, etc., you will inevitably see something like this. Now, I use two phrases that are very important to my way of thinking: inevitably and something like, to be faithful to science. I can't say necessarily, because then I deny everything I just said. And though I've done that on occasion, I prefer not to. And I said something like, because the chance processes or chemical decomposition could have been dominant at a certain phase, so that we would have arms that come off our belly buttons and our backs, and it would look funny, except we'd all be that way, so it wouldn't look funny. So I say inevitably and something like. I say something like because that's the nature of the universe. It doesn't allow anything to happen. The nature of the universe drives this process to the human being. Why is the human being at the top? Because we don't know what else to put at the top. The human brain is the most complicated mechanism we know. If you have a more complicated mechanism, we'll put it there. So that having been said, let's get to the question. It looks to me like somebody's been managing this process. It looks like it has a kind of a coherence and a drive to it. So did God do it? Did God do it? I don't know. There's no way I can know. I'm doing science. I'm seeking natural explanations for natural events. So if I haul God in, I'm betraying science, and God, by the way. Or if I throw God out, I'm betraying science and God, by the way. So we have to separate the two. We have to be very careful that we cannot conclude from this to the existence or the nature or the fact that God created the universe. That's my take. But if I believe in God and that He created the universe, and I do, then why isn't it fair enough for me as a religious believer to say what I know as a scientist about the universe, what kind of God that I believe made the universe would make a universe like this? And my answer is one marvelous God. God did not make a washing machine. You know, you store up the parts and keep it going. He did not make the famous sort of watch that keeps clicking along. He didn't make a car, certainly not a Toyota. God made a universe, now I'm speaking as a believer, but from my knowledge of science, that participates in God's own creation. It has a dynamism. It has a creativity. It has a non-predetermined nature to it. It's going into the future, and we don't know exactly where the future would be, except more complex from what we know of the nature of the universe. So I think that distinction is important if we're ever going to answer this question, to realize the inadequacy of the question, that it's both in a fertile universe, and therefore God can only be brought in from a religious perspective if we appreciate scientifically the real nature of the universe. Chance and necessity, I often say, dancing in a very fertile universe. So that having been said, I'd love to dialogue with you. My few sort of resume statements are these. I've said that. Why does it belittle God? I mean, if we have a God that made a washing machine, it's no God at all. If we made a God that predetermined how the universe was going to be forever, it's not the kind of God that loves me and wants me to participate as a co-creator in the universe. And this I've said pretty clearly from my own point of view. But the more interesting dialogue, and notice I put a big if here because religious faith is a big if. I mean, I had a conversation many times. He was a close friend with Carl Sagan, who many of you know. And we talked about these issues, of course. And I finally, I got desperate enough that I said to Carl, Carl, God, my faith in God is God's love of me. It's a gift of God to me. St. Augustine, I can speak of St. Augustine in this company, I think, said many times, especially in his Confessions, Lord, I searched you down the highways and down the byways. I searched you day and night, and I only find you, Lord, when I realized that you had found me. And I'm firm in that belief. It was God's motion to me, through my family upbringing, my revolts against the sisters who beat me and all this, but through growing into adulthood, I had no reason not to accept this love of God for me. So Carl Sagan says to me, well, George, how come you have the gift and I don't? Well, try that one out, folks. I was reduced to silence for a little bit. And then I babbled. I said, Carl, we were friends enough so I could say this. Carl, you either have the gift and don't realize it yet, because it's such a precious gift, and each of us walk our own walk, that it takes different ways to accept that gift and realize it, etc. Or if you don't, you will. That the God that loves me will not love all of his creatures, Well, Carl walked away and said, have a good time. But I do insist that the big if depends on how you view your religious faith. I certainly view it as I've never come to accept God's love for me through any purely reasoning process. I've had to make the leap into the process of love, of mutual love. But once I take that if, and I finally come back to the, why are we children of the universe? Because we, coming out of this universe in the way that I mentioned it, I think have a very special responsibility. We, above all creation that we know, have a creative power. Through science, through poetry, through literature, through sculpture, through music. We have a creative power. And I'm not limiting this statement to, ecological issues, though they are the most important, where we have the most immediate responsibility for the earth and the universe around us. But we are very special creatures in this universe, and that God made it that way. Well, thank you for listening. I think I've said enough.
We have some time for question and answer.
I really like your idea about the fertile universe. It's very familiar to me, or similar to me, to Kirtley Mather, who was a paleontologist at Harvard. Are you familiar with him?
Who's that?
Kirtley Mather.
Yeah, I know of him.
And is a wonderful book, Permissive Universe. And so I don't know if you're familiar with that, and if you could share your ideas about that.
No, I think from what I know of his writings and, people like Teilhard de Chardin, I think it's very prominent among solid scientists that see the universe as creative in this sense. From all of the disciplines, from biology, molecular biology, genetics, morphology, paleontology, physics, cosmology. I find little place for a clear exclusion of God, a la, Hawking and that kind of company. I just find that, their science is obviously exquisite. Their use of science, to say, well, it's simply absurd to say that if we do not need boundary conditions for the beginning of the universe in a quantum cosmological view of Stephen Hawking and others, then we do not need God. First of all, who told you, Stephen, that God is a boundary condition for the universe? And number two, who told you we need God? God is not first a God of need. God is a God of love. But it's hard to put that into the head of, I get carried too far afield. Most of these people, I'm not really accusing Stephen Hawking. They have no knowledge of the wider human culture, of religion, religious philosophy, literature, architecture, music. There's some people I like. There's some people I just don't like. There's some music I like. There's some music I don't. All of us, are inserted in human culture, which is vast. And to exclude a whole portion of human culture, from your sort of thinking about things, which a lot of these people do, a lot of these very positivistic, empirical scientists do. Well, Stephen Hawking is far from empirical, but okay, said enough.
So if humans are the product of the third generation of the sun, is it safe to assume that with the fourth generation, the fifth generation, that other creative beings will be product, will be produce something that we can't even conceive of now? Is there science that could predict what those kind of entities would be in time?
I don't think predictability is available to us because the time scale is so large for a generation of stars that it's hard for us to see where the process is going into the next generation. Not that there will not be, because stars are dying now and beginning to, supernova are going off and filling the universe with ever more. The universe is continuing to expand. But predictability in that process. But one can look at the past and say, it's going to be much more complex. I mean, just the advance in technology. I mean, I grew up as a teenager, I'm not that old. There were no television sets. Now you guys have television sets in your pocket, right? And that's only over a 50, 60-year period. So who's to predict what's going to happen in a couple million years? Which means, too, if we discover an independent intellectual civilization, it's almost certainly much more advanced than our own. And that may be why we don't see it, or they don't communicate with us. We're like little ants. Who's going to talk to an ant? Please.
So I wonder if, I was just struck by your sort of concluding remark about the universe being wonderful. Are there characteristics to the universe which we can extrapolate and apply to the Creator as, is that a valid or a sound way of thinking?
That's a very good question. And again, it's like my difference between proof and coherence. I don't know. I mean, what you're asking me, I ask myself all the time. When I take my scientific knowledge of the universe and say, what kind of God would make a universe like the universe I know as a scientist? Am I not running the risk of making God in my image and likeness? Making God fit my knowledge. And I have to yield. But I got to do it. I'm sorry. If I'm sinning, I'm happy about sinning. It's a temptation to... God is much, obviously, beyond any knowledge we can ever think of God. But we have to nibble away at it. I mean, theology is full with analogical thinking about God. That is.
Well then, how about the notion that increasing complexity is inherently benevolent? Or...
Oh, it's not. I only looked at the benevolent side for my own purposes. I mean, why do we have hurricanes, tornadoes, tsunamis, leukemia?
So we can't assume that we're moving in the right direction, that humanity is moving in the right direction.
Well, we seem to be more complex now than we were when we were crawling on all fours. I mean, that's all. I'm limited. It's a very limited knowledge. The human being has come out of a complex process that, as best we can judge, we're at the top of the heap from what we know of the heap. And if we didn't have leukemia, if we didn't have hurricanes, we wouldn't be here. So that's part of the process too. That's the way nature is.
So it's a mixed bag.
Oh, it certainly is. Please?
Is there an estimate as to the number of third-generation stars that are out there?
Yeah, about, in our own galaxy, about 2/3 are third-generation stars. They needn't be, there's a sort of a window around the type of star the sun is, so it's not just solar-like stars. Less massive stars will not have died as quickly, more massive stars more quickly. I'd say about 2/3 in our own galaxy, and you can extrapolate that to the universe.
A lot of planets out there.
Pardon?
A lot of planets out there.
Oh yeah, no, there are a lot of solar-like stars and a lot of planets out up until, the statistics we've done on nearby stars. We've only sampled what we call our local swimming pool. A couple thousands of light years out in a galaxy that's 100,000 light years across. So we've just sampled a very. Please.
Could it be that God had to allow us to have doubt in order to allow us to have free will?
Yeah. There's your answer is yes. Without free will, you cannot love. God's love for us is not love if it's not returned. So God took a risk in bringing about a universe that would bring about creatures like this who could reject God. Because if we can't reject God, we can't love God. And in some way, but in a very analogous way, that holds for what we call physical evil. Not moral evil created by free choice of human beings, but hurricanes and tornadoes and tsunamis and earthquakes and everything had to happen in order that the earth would be habitable.
Could it be true for a Christian? The only thing that makes sense is the cross.
It's a good time to be thinking of that during Lent, yeah. But in a sense, the cross you cannot think about in sort of natural terms. But without death, there cannot be life. So Christ's death was necessary in order that we would have eternal life. So it says in the scripture, unless a seed of wheat fall into the ground and die, you won't have any crop next year. And so that's seen in nature, and then the cross brings that to another level, of course. And of course, that's a supreme mystery. Why did God have to die on the cross? But there are too many theologians around. Please.
What are your thoughts on the technological advancement ideas of today, such as like singularity and transhumanism? What would God think about the ramifications of these ideas?
Yeah, it's, I would say way out, but I'm not sure that God would say way out, to be honest with you. I think that look into the future and all, I think should be encouraged. I don't know what transhumanism means, but let's not, if a few million years ago you talked to a bunch of monkeys, they would think this was crazy.
Almost like eliminating aging almost.
Yeah. Eliminating is easy, right? Go with it.
You think would a God approve of, eternal life or the advancement of computers past our intelligence?
Oh, I think absolutely, but I can't speak for God. You have to talk to him or her. But I'm almost sure the God I know would. Sure, he'd encourage that. Please.
So, could we just go back to the picture of the tree? Because, my question kind of relates to it.
Yeah, sure.
So, when you were talking about evolution, you mentioned that basically, if a simple organism does form, like an amoeba, it's essential that it'll evolve into something more complicated, like human brain. Say, if that's correct.
It's inevitable.
It's inevitable, right? That's the word we used. So at the bottom of the tree, we have the simplest creatures like the amoeba or whatever that forms, and that kind of evolved into more complex things that eventually goes to the human beings, which are most complicated. And you were mentioning that a god that would, say, create a washing machine, that wouldn't really be interesting at all because it's incredibly simple, right?
Yeah,
well, I'm wondering.
It would just keep turning around.
Yeah. Okay. So if you're so you're saying that God created the simplest creatures at the bottom of that tree, Like, say, the amoeba?
God created a universe out of which the simple creatures would come.
Okay, okay. So, but doesn't that make it like, so God's not creating anything that's infinitely complicated like a human brain, he just starts it out?
He's made a universe that God is, it's a good question actually, because it brings up something I should have emphasized. That creation is often thought of as an act of God that took place 14 billion years ago, and it's not that. God is continuously creating the universe. Theologians have a long, long history of this study of continuous creation, it's called. And the marvel is that we participate in that now.
Right, so you don't just think it's just something God set in motion like that and just left it alone there. You think it's a continuous...
God is continuously caressing, working, hoping, praying with the universe. They're all weak, but I think that's better than saying God designed it and said, 2,000 years from now we'll have this. 5 million years from now we'll have this. You know, he had it all sort of pre-planned. I'm not saying God couldn't do it, but he didn't do it.
I think there were 2 more hands
Sure.
in here, and then we'll call it a...
Please?
I was intrigued that one of your illustrations showed a galaxy or universe inside a human head.
Yeah.
And that reminded me exactly of the cover of Douglas Hardy's book, The Hierarchy of Heaven and Earth, Man's Place in the Universe. Do you know that work or Douglas Hardy's stuff? Can you comment on that idea of God consciousness being all pervasive, that it's not the universe is out there, but rather it's in us as we are aware of God, like cosmological?
No, I agree, but you know, my theology is really very weak. I mean, he's you know, I have to apologize to theologians, but all I can say on that, yes, is that God is present in all of human activity, especially in human consciousness. He's working with us, except those of us who reject God. And please?
Thank you very much for a wonderful lecture, and I particularly appreciated the emphasis upon human responsibility where you ended. But I'd actually like to come back to what would it mean to admit, if one believes in God, then science helps tell us about that God, correct? I mean, I think that's, well, doesn't that imply that science tells us that God is not always as benevolent as we would like to believe?
Correct.
And that therefore our conception of the divine has to be perhaps a little less rosy than has been presented.
Correct.
And therefore our responsibility has to be grounded in something other than simply the benevolence of God.
Correct.
Thank you.
No, I hate to be brief, but I think you're correct on all. And I would suggest reading anything that John Haught has written on this. He's a theologian at Georgetown University. He's not a Jesuit, so he's readable. Haught. Oh, was he? Oh, he's excellent. He's excellent. John is excellent. Because he's one of the few, I know there are a lot of theologians around, but of the theologians I know, he's one of the few who really understands the science before he talks about it. And that's rare. No, he's...
Thank you very much.
Thank you.